Hey everybody, and welcome back to another video. Today I'm going to be doing a quick tutorial on 16.3, the exponential smoothing from Pearson. So I'm just going to explain quickly what we are doing when we're smoothing a data set over a time series. Basically, when we have a data set that we've collected over a period of time, we're going to have some, for lack of a better term, strange events, some outliers, some irregularities that skew the trend, and we want to see the trend line more clearly. So we're going to smooth out those bumps and deep troughs by applying a damping factor to our previous year's value. And so the higher the damping factor gets, the more smooth it's going to be. And that means when alpha decreases, because the damping factor is 1 minus alpha, it's going to, as alpha decreases, it's going to smooth out our time series. So this is going to be an Excel tutorial. We're going to do everything in Excel. That's just the way they want you to do the labs anyway, so it's better. If you'll still be able to do it by hand if you really want to challenge yourself that way. All the formulas and everything will be here. So we're going to start by clicking on these windows and open Excel, and I'm not going to do it right now because I already have it open on the other side. But that's how you get it into your Excel, and you can get Excel off Outlook. I think it's better to download the application as opposed to using the web application that they have on Outlook. So download that, and we're going to move over here. In this column, I've added our alpha factor, and then the damping factor is just 1 minus that. We have our data set here, and we're simply going to start with the formula for smoothing. Two things. One, when we get to our predictions in the exponential smoothing section, it's really simple. It's just going to be whatever the value of 8 was and continues on forever. That's why these predictions you'll see always at the end, it'll smooth out and just go straight, which is why you're only supposed to predict for the given interval range that you have, or just a couple after. You don't want to the further you extend past your set, the more it's gonna get wild. You want to see these short-term trends of your data set. So let's go ahead and start. The first value for our smoothing is always going to be the first value from our sample. That's 1.46. And then we're going to build off from here. So first thing we're going to do is the equal sign to start our formula. We're going to do the damping factor times the first value of our new, what they call x hat t minus 1. And so what this is doing is saying, so we're doing the damping factor times the factor just before this one. So the way you can look at it is that we have two values here. We're going to be doing damping factor times x hat t minus 1, which is 1.46, plus the alpha factor times the current reported ratio for year 2. Now, so what this is doing is that both the alpha and the damping factor make up 1% or 100%. And so we're creating a new value based on the value reported and the value that comes before. And so the higher the value in the damping factor, the more we're gonna favor the value that came just before. Thus, that's why it looks more smooth, because we're building a new graph, and if it's always valuing the one before more higher, then there's going to be less differences each time a new value pops up, because it'll be taking more of this one as opposed to what was reported, which is why it starts to smooth out. So that's why when alpha decreases, our damping factor increases, and it gets more smooth, because we're valuing the value that's always right before this. And so if we're always valuing the value right before this, the one that's not reported, that's built by the formula, it's going to look as if it's almost going to be, relatively the same, because we're always going to be valuing this formula more. It's going to be taking a bigger chunk out of this one as opposed to this one, making sure that these are all going to be relatively the same as they go along. As opposed to where if alpha was larger, which is this is the case, it wouldn't be so as smooth as we'd like it to be, because it'll be valuing the reported ratios as opposed to what we're building, right? So if these ones are very far off from being close together, then it's going to look like that over here, because we're valuing what we got in the actual sample more than what we're building through the formula, through whatever was last. So you'd probably want to use smaller alphas when the values are already pretty smooth, and then we can see the trend clearly, and there's no need to start messing around with the numbers trying to get them closer together if that's how it is. So let's get started. I've typed in the formula here, which is alpha times x of t, x in period t, and the damping factor times x hat of t minus 1. And we're going to apply this formula to all the cells. And to do that, we're just going to put a command, if you're on a Mac, I think it's the same on Windows, but it's command T, which fixes the alpha and damping variable to whatever these boxes. These boxes aren't going to move as the Excel applies. So the ones without command T are gonna move down progressively as the cell moves down, but the ones with command T will be fixed on the values that you have left in the box. So let's enter that and apply it to all our cells up to 8. And in case you're wondering, I've already shrunk the decimal points down to 2, so it's always running to 2 just as they want, and you can find that. I think I have the screen cut off, but you can find that right about here. It'll be right under general where the $sign and percentages. You'll be able to move the decimal back and forth. And so once you have your data set, it's simple as once you get to the end, it will always be the same value as the last reported value. So in the last cell where you have the reported value, you want to use this one for the rest of the reported one, which is why in this early section you'll see in your graphs that it'll form out to a straight line. And that is exactly why you don't want to predict too far. You want to just add a couple to finish off the trend and leave it at that. So yeah, here are the answers, and then you could take it and directly enter it into your Pearson lab. So I hope this helps, and I'll see you again for another video. Thanks.